Hello everybody, welcome back. We're going to be looking at the build-up rate for a 230 wall, and familiarize yourself with this image in front of you of this masonry wall, the illustration, and if you've forgotten these things, maybe you can just revisit the video on how the construction process takes place. It's on this YouTube channel, the Shumba Food Creative Space YouTube channel. Without further ado, let's move on and look at a full house so that we see where this 230 wall is built. Is it the exterior or the interior? It can be both exterior and interior, or it can just be exterior in some cases. But let's just get to see where it is applied and what we're going to be looking at as the business of today. Okay, so that wall that you're seeing is basically that brown part of that house that you're seeing, that building that you're seeing. Usually we call it the superstructure wall or superstructure brickwork. In our case, you're going to see that we have that black part, that black region in black below the house. That is the foundation, the substructure. And then from the NGL, it means natural ground level. That's where the ground is, where you're stepping, the surface, and then from there going upwards to the roof, that is the superstructure. So we're going to be concentrating on the wall in the superstructure, which is that brown area that you're seeing there. That's the one we're trying to price. We're trying to price per square meter, so it's just a square meter of that entire wall that we're going to be pricing, so that it's easier for us to use a rate for different parts of the building with the same quality of the wall and the same dimensions of the wall. So let's get on with the business of today. Okay, so majority of the stuff that you're seeing here in the introduction or preface were explained in the video on the concrete 20 megapascals, the build-up rate for that type of concrete. So if you watch that video, that's the previous video, if you watch that one, you understand what I was explaining here. I explained a lot, so just visit that video. It's just a little bit of things that we have changed. If you see on the components of the unit rate, we are not going to be using the plant and equipment. We're not going to include it in our calculations because we're going to be assuming that the people are going to do the work of mixing the mortar. But when it was with the concrete, it was going to be a bit difficult for the people, so we had to factor in the plant and the equipment, like the concrete mixer, the vibrator, and the like, so that at least we account for the machinery that will be used to help the labor in doing the work. So you can just read through and familiarize yourself with what we're going to be dealing with. Otherwise, let's move on to the quotation. Okay, so assuming that you watched the video of the build-up rate for the 20 MPa concrete, then it means you're going to be able to understand what's written here, the quotation, and how it looks like. There's only a few things that have changed, like the materials have changed. I've put a list of the materials that are needed for the building of a wall, the 230 wall. We have common bricks, we have cement for the mortar, as well as the pit sand for the mortar, and then we have the brick force for reinforcement of the wall, and then we have the 2-ply DPC for the damp proof. The DPC means damp proof course, which is a material we use to separate the wall from the underground water and moisture that may damage the wall. I think we all know what happens to walls when they become damp, especially with the plastering and the mortar between the bricks and the like. It would weaken the wall, so we have to factor in that thing. So that's the quotation for all the materials. Quantity is 1, like I said in the previous video. The text we had explained that it's determined by the regulation of from the revenue collection authorities, and we have also the page number, meaning that it can be more than what's on that page. You can have a lot of materials that are being sold at the hardware, so you need to factor in that. And how we come up with the total and the subtotal and the value added tax, I explained in that video. And so you just watch that video and then you get to understand these things. But it's basically subtotal plus the value added tax will give you the actual total cost of the materials that are on the quotation. So we use these prices of each material. We're going to use them in our calculations, as you're going to see just in a moment, which is the same thing we did with the concrete video. So if you haven't watched that video, go and watch it. It's a bit lengthy, but it explains everything. I'm trying to make this video short so that you are able to understand things a bit faster. Okay, as you continue from here, even from the quotation part, just make reference to the first two diagrams that I showed you, the first two illustrations of how the wall looks like and where it is built and all the things, the components of that wall. So let's move on. So you're going to start with the bricks. You're going to see that there are things that are not going to include, like brick force. It's not going to be included, and also the DPC. We calculate those separately. So we're just going to continue with these, the other three, the pit sand, the cement, and the bricks. So we're going to start with the bricks. So the standards that we have, we're going to be using the standard in Southern Africa, particularly in Zimbabwe. So there are 104 bricks per square meter for a 230 wall in commons. In commons means common bricks, the one that you saw on the with the price on the quotation. Then built in a stretcher bond, like what you saw in the diagram. That was a stretcher bond that you saw, how the bricks are going to be arranged as they're being laid. And then excluding wastage, so we have to also account for wastage, which is what we're going to be doing next. So it has been stated that these things are like that, but it's excluding the wastage. So making allowance for the wastage, we're going to make an allowance for around 5% of bricks per square meter. Okay, so we're going to say that 5% we add it to 100%. 100% meaning it's 104 bricks per square meter. So we're going to add more bricks, just a few more bricks, 5% of 104. So a shortcut, without having to do it one by one, we just say 100% plus 5%, which gives us 105%. Then we say 105% of 104 bricks. Easily we can just say 105 over 100 multiplied by 104, or we can just say put it in decimals, becoming 1.05. So it becomes 1.05 times 104 bricks, or 105 over 100 multiplied by 104 bricks, which gives us 109.2 bricks per square meter. It's written per square meter because we're saying for each and every square meter we're expecting to be using 109.2 bricks. We will need 109.2 bricks per square meter, so that we cater for any wastage that happens and we won't be disadvantaged. We will always have to achieve that required number of bricks per square meter, which is 104 bricks per square meter of that 230 wall. Okay, now we move on to the cement, which is a bit harder than the brick one, because the brick one, we're just saying our quotation, the bricks are being sold in terms of bricks. So if we just calculate the number of bricks we want, we then multiply with the rate, and then we get our final cost for the bricks that we need per square meter. But here with cement, it's a bit different, because the standard estimated volume of mortar required for the 230 wall is in cubic meters per square meter, and we are dealing with dollars per square meter. That's the rate that we're going to be using. I had forgotten to mention that before we started this video. It's dollars per square meter. That's what we're going to be using. You can use pounds per square meter, pula per square meter, rand per square meter, Namibian dollar per square meter, whatever money, euro per square meter, yen per square meter, yuan per square meter. You can just use whatever price, but make sure that it's according to the quotation in that country where that currency is being used. So you have to be mindful of that, and you have to also be up to date because prices change. And then the mix ratio of the cement to sand mortar is 1:4 for the mortar that we're going to be using here. And then making allowance for shrinkage, that's 20%, is different from the previous video, we're at 25%. And then for wastage, we're at 10% of mortar, which is different from the bricks. From the bricks, we're saying we are going to make sure that for bricks it's a fixed amount of bricks, so we can control the wastage, right? We can limit the wastage. But as for mortar, it's a bit different. It comes when it's in its molten, okay, not molten, but like in a slimy form, not really watery, almost watery, but not really watery. So there are chances of us losing a bit of mortar, maybe when we're transporting and the like. We are trying to use conditions, we're factoring in the conditions where we're not using machinery, but we're just having labor doing the work, like what is mostly common when building residential buildings. So that's what we're going to be, that's the scenario we're dealing with, where we don't have that equipment. That's why we have excluded the plant and equipment component. Okay, so let's move on to how we calculate the allowance for shrinkage and the wastage. We just say the 0.096 cubic meters per square meter, which is the standard that we have seen for mortar, multiplied by the 100% plus 30%, which is the same method we're using for the bricks, to say 100% plus 5%, In this case, we're now saying 100% plus 30%, allowing for shrinkage of the mortar and the wastage of the mortar during use. But we have to make sure that we don't waste a lot. I think that's one thing that we also need to take into account. But since we're human beings, there's some error that can take place, thus leading to the wastage. So just have to factor in that. So then multiply that and then get 0.1248 cubic meters. Pardon me. So that's the volume when we include the wastage and the shrinkage. And then therefore the ratio of cement by volume, we just say 1 plus 4 is 5. So it's now 1 over 5. So a fifth of the material used in the mortar is cement. It constitutes a fifth of what's used in the of the volume of the mortar. So we estimate that we need approximately 30 bags of cement per cubic meter of mortar. For that mortar, we need around 30 bags to achieve that. So therefore, the bags of cement required, we then multiply 1/5 of that volume that we got after factoring in wastage and shrinkage of mortar, and then we get our value, the volume, which is 0.02496 cubic meters, and then we multiply that volume with the number of bags. So it's number of bags per cubic meter, which then gives us 0.7488 bags, which is approximately equal to 1 bag. So you can just buy 1 bag and you achieve your 1 square meter, the cement needed in 1 square meter of the wall. And then that note at the bottom there, it's basically explaining what I was talking about when we now apply the shrinkage and the wastage component of this calculation. So just familiarize yourself with this section. Now we move on to the pit sand. Alright, then the sand part, we are going to use the same value, 0.1248, where you see that last statement, volume after making allowance for shrinkage 20% and wastage 10% of mortar, will be 0.1248 cubic meters. So that's for the square meters per square meter. So it's cubic meters per square meter. So we know the ratio will be 4 over 5 for sand, because it's 1:4, 1 for cement, 4 for sand. So the sand one will be 4 over 5, and we need 72 bags of cement per cubic meter of mortar. We'll then need to convert to bags as well, because our quotation, we are getting this thing sold per bag, so we need to understand that. And the bags are actually 50 kgs each, which is different from the concrete video where they were a bit different, the masses. So we had to factor in that each calculation for each of the materials with the different masses of the bags. So the calculations are just basically the same thing that we did with the cement part. So just go through and then you see how we calculate. It's the easy part, so it shouldn't be very hard for you to understand. I explained everything for the cement part. This one is straightforward. So let's move on to the totals. Alright, so for materials, we are going to mix the mortar as 1:4, cement sand mixture respectively, so don't forget that. Then also our market prices for the materials include the transportation to site, and also VAT, which is the value added tax. Alright, and then you can see that in the table we have the materials that we're looking at, the cement, sand and brick. And then we have the quantity and units of the materials, which the cement and sand are in bags because they're being sold in bags according to our quotation. And then our quotation was saying bricks are going to be sold per brick, so it's 20 cents per brick. So that has been put there. So it's $10 per bag of cement, or per sack of cement, and then 1 bag of sand costs $5. So that's those are the rates that we're going to be using, and then we just multiply each row, the numbers in each row, to get the amount, and then our total will be $65.29 for all the materials per square meter. And then we can look below there, which is the calculation of all-in rate of the materials when we exclude VAT. Let's say VAT was not included, so we then take our $65.29 as the subtotal, and then we calculate 15% of that. The 15% is usually a constant according to the laws. It can be any percentage depending on which place you are coming from, which country you are from, so it depends. And then you get to calculate using that, and then you get your final answer, as you can see written there. So that will be the total in blue there. So the $65.29 will be the subtotal, and that total will be the total after adding the value added tax. So I hope that is simple and straightforward. Let's move on to the labor component. Okay, this is the longest calculation, probably the hardest, because there are many things to consider as you're calculating the costs for the labor. But don't be intimidated. There's nothing hard there actually. It's only hard when you are not familiar with how to get the shortcut and the tricks and where to get the values and all those things. So like I said previously, we have standards, as you can see in the first paragraph there. It's talking about where we get those things. We have laws that govern those considerations, the factors that we consider in calculations, and the prices of things, and the remunerations, and the tax, and all those things. They are determined by the laws that govern the jurisdictions, the different areas that we live in, the different countries. So what we are going to work with here is usually what's common in Southern Africa. We have a skilled worker and two worker grades. These worker grades are the unskilled workers, the assistants of the skilled worker. So the skilled worker will be paid $3.50 per hour, and then the two unskilled workers will be paid $2 each, which the total will be $4 for both of them, which is different from the concrete video. There is another pricing that we used for the concrete, so the costs were also different, a bit higher, and also we had three unskilled workers and one skilled worker. So the gang had 4 workers, but here we're going to have 3 workers in the gang, which are expected to lay at least 450 bricks per day. And a day in the construction industry, according to our standards, is around 8.8 hours. So we have to consider that, and then we have to remember that we have 104 bricks per square meter. Don't forget that. Therefore, the total cost for constructing the wall, including transportation and placing at the place of need, like taking from the pile to where the wall is going to be constructed, excluding mixing the mortar, that's very important, will be equal to $3.50 plus $4 multiplied by the number of hours. So we are going to get the total money that are going to be paid per day for both the skilled workers and the unskilled workers, which is around $66 per day. But just for the worker grades, because there's something that we're going to be using that only needs the unskilled workers, and the skilled worker will just be a supervisor, which is the mixing of that concrete. So we're going to just need the unskilled workers to mix the concrete, which means we need to pay those $35.20 per day, the 2 unskilled workers, which is the total. So we just divide by 2 to get how much each will get per day, on top of the one that they're going to be paid for the bricklaying. And then the work output in terms of square meters per day, we will then use the because we have 450 bricks per day and 104 bricks per square meter. So remember, we're going to be needing per square meter. So then say that 450 divided by 104 to get the 4.33 square meters per day. And then we are going to say mixing mortar by hand takes 8 hours per cubic meter. That's another standard that we need, because we are going to now want to calculate the hours that need to be used, or that need to be considered when we have that mixing of more concrete than usual, because we're expecting the concrete per cubic meter, but we then have that extra 30% that we've added due to shrinkage and wastage, so which means that it is more work, so we need to increase the time. So instead of 8 hours, we need more time for them to mix the extra concrete, which then gives us the new time is 130%, which is 1.30 exactly, multiplied by the 8 hours to get 10.4 hours per 1.3 cubic meters of mortar. So it's no more just for 1 cubic meter, we are now mixing 1.3 cubic meters is the rate. And then the volume of mortar that is to be mixed per day, we then say the 8.8 hours divided by the 10.4 hours of mixing the mortar, because 8.8 hours, that's the one for the hours of per day that we expect the workers to work per day. But we then have the 10.4 hours for just mixing the concrete, rather mixing the mortar, my apologies for that, and then we multiply that with the volume that they are going to be mixing, which is the 1.3 cubic meters, and then we get our answer, as you can see right there. And then we say the 1.1 cubic meters Right, now we are looking for the square meters. So we're using cubic meters, but remember our rate, the final rate that we're supposed to have, it's supposed to be dollars per square meter. So we need to convert from cubic meters to the square meter. And then we say 1.1 cubic meters divided by the cubic meters, divided by the cubic meters that we have of the motor per square meter, which is 0.096. I think you can remember that from the previous calculations. Multiplied by 1 square meter, because we're trying to look for 1 square meter. So we're saying 0.096 is for 1 square meter. What about for 1.1 cubic meters? And then that proportion, we calculate using proportion. That's what we're doing. And then we get our 11.46 square meters per day. So that's the square meters that we're expecting as per day. And then now we can calculate the total rate for the labor component, which is the sum of the cost for labor when laying the bricks, when building the wall, and the cost of the labor for mixing the mortar. I think you get that, because we calculated them separately for the bricks, for the building of the wall with bricks, and for mixing the mortar. Okay, so for the bricks part, we're going to say the $66, I just said at the top there, $66 per day, divided by the 4.33 square meters per day, which is for the work output that you're expecting in terms of square meters per day. So it's the amount of money we're paying the skilled worker and the unskilled workers total, which is $66 per day for the bricklaying, plus divided by the square meters per day, so that it becomes the dollars per square meter. And then we do the same for the mixing of concrete. I'm thinking about concrete, just pardon me. It's supposed to be mortar, mixing of the mortar that is used for bonding of the bricks. We are then saying the $35 that we calculated, $35.20 per day for the unskilled workers, the 2 unskilled workers, divided by the 11.46 square meters per day of the mortar that is being mixed. Because we're saying we're excluding the skilled worker because he's the one supervising, we're not going to pay that for that we're not going to include it in our calculations. Because we're mainly concerned about the labor and not just supervision, but the labor that is being put into mixing that concrete. And even though we can say that when these people are mixing the mortar, I keep on saying concrete, they're mixing the mortar, this skilled worker will be busy building the wall, covering ground in terms of building the wall. So it's already balanced there. So I then add the 2 fractions, and then we get our total labor cost as equal to $18.33. So that's per square meter. So we're expecting to then pay them $18.33 per square meter for their job, both for the bricklaying and for mixing of the mortar. So let's move on to the last component, which is the profit. We're not going to be looking at machinery, like I said, but you can include plant or equipment. For example, mixing with the concrete mixer, you can use it to also mix the mortar. Yes, some people use it to mix mortar as well. There's one which is multifunctional. It can also be used to mix mortar. So instead of these unskilled workers doing the job of mixing mortar, they can use the mixer to mix the mortar, and all they have to just do is then transport that mortar to where it is needed. So that is catered for there. So yes, that's the cost, and I think we have understood everything. If you haven't understood, just read through and revisit and see how it is done. But I think it's clear. Even if you were to read, it will be very clear for you to understand where the values and the calculations are coming from. So let's now move on to the profit and overheads. Okay, so the final stretch, we have arrived. We have the profit and overheads, which is the D part. I think you can see the numbering is a bit different, but basically there was a typing error there where it says profit and overheads D. It's supposed to be C, as you can see with the totals there. So just pardon me for that. But we're going to look at how we are going to assume these things. Okay, we're going to say 20% of the total cost, from the total being that of materials plus the labor cost, as you can see, which is the $65.29 that we got from that table where we added the cement bricks and the sand, and then the $18.33 from the bricklaying and mixing of mortar, and then we find 20% of that, which is $16.72 per square meter. Remember, everything is supposed to be per square meter, dollars per square meter. That's where we are supposed to arrive. So whatever method you use, whatever way you calculate, we have to end up with the dollars per square meter for this example. Unless if you're using any other unit. But for this unit rate, we're going to be using a rate of dollars per square meter. That's our rate. Then the summary and totals. So basically we had materials, labor, profit and overheads. We just add the three values, the three amounts, and then we get our total cost per square meter being $100.34. So we're expecting that when we are building our wall, each and every square meter of that 230 millimeter wall will cost us $100.34 for everything that will be needed for that square meter of the wall. So all we just do now is to say how many square meters of 230 millimeter wall do we have right around the house. You saw that house that we had at the beginning of this video, that one with the brown walls. The brown part is the paint and all that, but excluding the paint, just the wall with the bricks and all the materials listed in the quotation. If you just go right around the building and calculate the square meters of all the 230 millimeter thick wall, you then multiply those square meters with that with the $100.34 to get the total amount of money needed for the entire exterior wall, which is 230 millimeter thick. But it depends with the house. Some houses may have the interior is 230, but our house here is a 230 millimeter thick wall. As you saw with the previous videos that we've done from our building, our construction videos on Shumba Food Creative Space. So I think we are done with the calculations. So this is how we come up with the prices. For those who just got to know now, at least you got to know these things. I've tried to go fast with this video so that I don't take more time with compared to that of the concrete video. So if you need more clarity on how to do these calculations and the procedures, including the plant and the equipment, you can visit the concrete 20 MPa video, building up rate for that concrete, and you'll get more detailed explanations on how to calculate these things. As from me, today is Heritage Day for South Africa. So since we're dealing with Southern African standards and building construction, we can just acknowledge that today one of the countries in Southern Africa is celebrating Heritage Day, just celebrating the cultural wealth and heritage that is within that rainbow nation, that country full of a lot of cultures and multiracial people, which are diverse and united. That is, I hope I've said it right, the Khoisan word statement for diverse people unite, which is the motto for South Africa. So yeah, I hope they are enjoying their day there, and we're also enjoying that day together in Africa, just celebrating our heritage and culture. So as for me, I think we're done with this video. As always, cheers.